In section 4.6, we're solving logarithmic and exponential equations using the properties of logs and exponents that we've learned throughout this chapter. There's one more thing I want to point out before I can continue with these examples, and that is the domain of log functions. When in chapter, what was that, section 4.4, when we first learned about log functions, we discussed the fact that the log of any base, numerical base of a quantity is such that the domain, the values of x you're allowed to use, the domain has to be positive. You're not allowed to use any values of x that are 0 or negative. So when you're finding your answers to these equations, do a quick check to make sure that your answers are going to be within your specified domain. So for example 12, we're going to solve this logarithmic equation. The goal is to get the logs by themselves on either side. And so I need to have a logarithm that does not have any constants in front of it or that's added to any pieces. I need a log of something equal to the log of something. And once I have that format, my logs drop off. All right, there's a property that tells you if you have the log base A of B equal to the log base A of C, well then B has got to equal C. B has to equal C, no matter what the log base is. And so that's what we have right now. We have the log base 4 of x to the negative 2 equals the log base 4 of 9. So the log base 4s cancel out. They go away. They don't cancel each other out. You can't divide by the log base 4. What's happening is you're raising each side as an exponent, and it's magically going to disappear. So for now, we're just going to pretend like they do cancel, because they go away no matter how you think of it. And this is what you're left with. X to the negative 2 equals 9. We have to solve this equation for x. You might start by writing the left side is equal to 1 over x squared. That would make sense since it's a negative 2 exponent. You can bring it down to the denominator, make it a positive 2. Maybe write that 9 over 1. Okay? And now you've got a fraction equal to a fraction. And in a proportion type equation, we can cross multiply to get to our next step. So I'm going to do that here. I'm going to get 9x squared equals 1, right? Now you're solving for x, so you have to divide by that 9. Now you have x squared equals 1 over 9, and you have to get rid of the square. The way we do that is by square rooting, but we need to remember to make it plus or minus whenever we take a square root of both sides. Now it looks like your answers are either going to be 1/3 or negative 1/3. But there's a problem with the negative 1/3. If I try to use negative 1/3 back into my original equation for the value of x, you're going to see that it's going to give you, well, it is a negative 1/3, right? It's not going to give you anything. It is what it is. So the negative 1/3 is not a feasible answer. It's not within your domain. The only answer we have from this solution set is the positive version, x equals 1/3. So when you're solving log equations, you always have to go back and check to see if your answers fit within the domain of your log functions. For 18, we're going to use a property of logs that allows us to bring those two logs together that are on the left-hand side, right? So when we're adding two logs together, we have a property that says you can write that as a product, the log of the product of each component. Now, it doesn't say what the base is of this logarithm, but does anybody know what it is? And you're all screaming at me right now, it's base 10, it's base 10. Yeah, it's a common log. It's not specified, so it's understood to be base 10. So think of this as, let's go log base 10 of x squared minus 21x equals 2. And then there's a way that you can rewrite this log equation as an exponential equation. The exponential form of the equation that we've learned is where you take the base 10 to the exponent 2, and that's equal to what you took the log of, right? So this line right here is log form. We call that the log form of the equation. And the line right below it, we would call the exponential form of the equation. So if you need some more practice, go back in your homework, or you can just simply Google log form to exponential form, and you'll see lots of different ways of that being explained. All right, well, 10 squared is 100. Let's just call it 100. And I'm going to try to solve this equation for x. I noticed that there's an x squared term that's quadratic. So to solve quadratic equations, you want everything on one side equal to 0, right? Because now we want to try to factor that equation. So try to think of two numbers that multiply to give you negative 100, but add to give you negative 21. So you're thinking 5 and 20 might work. No, 4 and 25 might work. That sounds kind of promising. How about minus 25 and a plus 4? And you're going to do a quick FOIL to check to make sure that you've got that factored correctly. And we do. So now you're going to get two answers. You're going to set each factor equal to 0. You're going to get x equals 25 or x equals negative 4. And then you go back and you check to make sure that these are both within the domain. Substitute 25 in for x right here and right here. Make sure that you're taking the log of positive quantities. We are. Substitute negative 4 back in for x in both places. Those are both bad because it gives you negative numbers in both places. Negative 4 doesn't work, so you cross it out. The only answer is 25. Question number 30. All right, so what we want to do is try to condense the two logs that are both on the left-hand side of the equation back into one log. And so I know that the difference of two logs can be written as the log of the quotient. All right, so that's your first thing you need to recognize is you can write the difference of logs as the log of the quotient. The next thing you might want to think about is factoring what's inside the expression, because we want to try to simplify that as much as possible. So it does factor. It's the difference of two squares, and now the x plus 3 factors will cancel each other out. So now it's log base 4 of x minus 3 equals 3. And I'm going to rewrite this now in exponential form. This is the log form of my equation, and I want to write that as an exponential form of my equation. So that's going to be base 4 to the exponent 3 equals x minus 3. Those are the particular spots that everything needs to fall into. Okay, so let's go up here. 4 cubed is 64. And you add the 3 to the other side, you get x equals 67. And you go back and check. Something doesn't look right. You go back and check. Yeah, it looks good. To make sure that 67 is going to fall within your appropriate domain by substituting 67 back in for x here, in for here, and you're taking the log of positive quantities, so everything is fine. For exercise 34, we are solving this log equation. You know what? I'm actually going to pause here and take a break and then make a new video for the last page.